Solving this problem, we have the height of this wall to be 4 meters, and we have the height of the second wall to be 6 meters. So the question is, what is the height of the man? Now, to make it easier, let's call the height of the man h. Now, there's a rule called the intersecting line in geometry, and which is going to be simple. I'm going to use two methods here. So the first method is here, our height is going to be equals to, coming to this problem, this is going to be my h1, and this is going to be my h2. Now the height of the man is going to be the product of the two heights divided by the sum of the two heights. So the product of the two heights, which is going to be 4 multiplied by 6 divided by 4 plus 6. So the product is going to be 24 over 10, which is 2.4 meters. This is a very short approach and a very concise one. But let's look at the alternative way of doing this, in which we're going to be making use of the slope. Now, going to this problem here, let's look at the coordinate of each of the points. Here we have 4 meters. So at this point here, we're going to have your x-axis is going to be 0, 4. And at this point here, we have 0, 0, because this is the origin. And here, let me call the distance here is going to be d, 0, because here y is equals to 0. And at this point here, we have d, 6. Now, I need two slopes. For the first slope here, I'm going to consider this first line. Okay, this is going to be my m1. And also for the second slope, which is going to be m2. Calculating m1. My m1 is going to be, remember we use this method of y2 minus y1 over x2 minus x1 to calculate the slope. So going with this example here, the first coordinate I'm going to be using here, I'll be using 0 to 4 to d to what? To 0. That is, I'm considering the first slope here, this slope. Okay, this slope. This is the one I'm considering. And here, I'm going to have my m1 as 0 minus 4. Or you can put it this way. You can put it as either way. Yeah. Either way, you can use the other approach. Yeah. Which is going to be y2 minus y1. This is x1, y1. x2, y2. Okay, y2 minus y1 is going to be 0 minus 4 divided by x2 minus x1, which is d minus 0. So here I'm going to have negative 4 over d. To form the equation of the straight line, recall that the equation of the straight line is y equals to mx plus c. So in this case, our equation of the straight line is going to be our intercept, which is 4, minus 4 over dx. Our m is negative 4 over d. This is the first part. Also, for the second part, which is considering the second slope is going to be this one, triangle, which is d to 6 and 0 to 0 here. So here we are from 0, 0 to d to 6. Now, our second slope, which is m2, is going to be 0 minus 6 divided by 0 minus d. So here we have 6 over d. In this case, our intercept is 0. So our equation of a straight line is going to be 6 over dx. Now we have the first equation of the straight line. I'm going to call this my equation 1, and I'm going to call this my equation 2. Now let's equate equation 1 and equation 2. That is, to find the intersection. So we equate our first equation to be equals to the second equation. And recall that the first equation is 4 minus 4 over dx, which is 4 minus 4 over dx, to be equals to 6 over dx. And with this, we have 4 to be equals to 10 over dx. So by making our x the subject of the formula from here, our x by simplification is going to be 2d over 5. The next thing to do is to plug in x to be equals to 2d over 5 in equation 2. Now our equation 2 here, we have our equation 2, which is y equals to 6 over dx. So here we're going to have 6 over d multiplied by 2d over 5. So here, d cancel out d. And from this, our y can be equal to 12 over 5, which is the same thing as 2.4 meter. So this is the point of intersection. Thank you very much for watching. If you have alternative way of doing this, kindly put it in the comment section. I'll be waiting for your feedback. Thank you.